This video provides a user-centered overview of the Synavis framework for plant sciences as well as some technical information on how to set up synthetic data pipelines. Let us have a brief look at the Unreal Engine for anyone who isn't familiar with it. The Unreal Engine contains a state-of-the-art visual editor for virtual environments. On the right, we have the outliner containing objects in the scene, as well as the property editor containing certain exposed properties, both from the C++ code as well as from the editor itself. The viewport contains all editor-relevant components, but not runtime components or spawns. Overall, Unreal Engine serves our purposes well because of its customizability. Synavis further integrates mostly unseen, as its primary purpose is coupling. The performance measurements provided in the paper are measurements acquired from a cross-compiled application. This means that in our usual development workflows, we build and package the application not on the cluster but on the personal PC. One key advantage of using a graphics engine with loose coupling is the fact that resources are available to researchers because of the wide use of the individual components. Synavis UE is an Unreal Engine plugin, which, in addition to activating pixel streaming, also functions as message handler. You can get the plugin and also the Synavis library from GitHub. If you already have a project, you can add Synavis UE to it. Otherwise, you can download one of the examples. The Synavis drone contains two cameras, a scene camera and an information camera for pixel-level data. The scene camera, for example, will write what is visible to it onto a texture, which is mapped back to the screen. If custom pawns are meant to be used and the camera re is just for the training and does not actually encode the behavior that is desired, for example driving crop roboter, you can also set it to not possessing control of the application. By default, the camera will choose points within the fly space to fly to. You can also tell it to fly to a specific spot via Python. Pixel level information can be set at runtime using the information camera provided with the Synavis drone that can be rendered side by side or exclusively. Segmentations generally work via custom stencil rendering, or alternatively hiding of individual geometries as part of the hidden actor list of the different cameras. Distance measures can be extracted for this camera as well. These are float values in centimeters within Unreal Engine, so as part of the image projection of these measures, the channels should be used wisely such that the distance information has as much resolution as possible. In Synavis Unreal Engine, this is done via the bint distance rendering mode. Let us have a look at coupling via Synavis. Pixel streaming is a plugin granting web browser access to a rendering backend. The actual application part of the pixel streaming plugin is encoded in the app.js code. If you take a look at the communication, you'll see that interaction mainly rests on signals about hardware events as well as signals about application data. Since the Unreal Engine uses WebRTC, it does not actually care whether there's a user on the other side. Furthermore, video transmission is mainly described in the session description protocol and other communications which we can automate. By putting more automatic behavior towards the actual game within the Unreal Engine, we can produce a training environment that is able to handle sparse communication. This game handling part is what the Synavis Unreal Engine plugin does. JSON communication between the Unreal Engine and the Python frontend works through the data channel handling in Synavis. In this cluster example, top middle shows the log of the running Unreal Engine. The build will try to automatically seek out any drivers or encoders it might need. Note that this should run on a GPU able to render graphics in Vulkan. Synavis also includes a signaling server that, in addition to its usual functionality, also has some connection and network interface handling, so that it automatically seeks out the InfiniBand interface. As you can see in the GPU usage measures, we have quite regular PCI throughput to load additional resources onto the GPU. The Unreal Engine usually keeps at least one GPU very busy, so we generally recommend to do any training tasks on the different node. We interact with the scene based on prompts. Other forms of scene interaction are tracking to receive frame-wise measurements and steering, either of the environment or of the virtual agents. Unreal Engine is so useful for plant sciences partly because of Lumen, which is its fully dynamic global illumination method, handling light impact, reflection, and bouncing. In the simplest example of the open world map that is part of the Synavis Unreal Engine example, you can, with a few steps, spawn as many geometries into the scene as is manageable by the engine. The only steps required for this are a basic C++ simulation, the visualizer described in the paper, and Synavis with Unreal Engine. If we move to more sophisticated approaches, you need some kind of surface texturizing. We do this by describing parts of the surface that will be repeated or stretched. By composition rather than perfect modeling, we can achieve more highly detailed scenes depending on the use case.